makes this problem hard. Let's say it says that we are given an array of integer called as ARR. We have to return true, again return true, if the number of occurrences of each value in the array is unique. So number of occurrences is nothing but the frequency, and the frequency of each value is like each value in the array is nothing but key. Like for us the key is this, and the frequency for them is actually the value. That's how we go about, right? And if it is unique, which means all the frequencies and frequencies of what, of the keys should be unique, and we have to return the false otherwise. So we will see, okay, 1's frequency is 1, 2 and 3. Okay, its frequency is 3. 2 frequency is 2. 3's frequency is 1. So we have got the frequencies of all the values in the array. This is the values in the array. This is the frequency of them corresponding to each of the values, and you will see all of them are unique. You just have to figure out if all of them are unique, simply return the true. If not, then okay, 1's frequency is 1, 2 frequency is also 1. So for all the values in the array, the frequency is this, and these are not unique. You can see 1 is repeating, so return a false. As you can see here, -3, again negative elements can also be there, so simple. -3 frequency is 1, 2, 3. Okay, its frequency is 3. 0 frequency, let's cut it out. 0 frequency is 1 and 2. Okay, 0's frequency is 2. 1 frequency 1, 2, 3, 4. 1's frequency is 4, and 10's frequency is 1. So you can see for all the values in the array, the frequency is actually unique. Thus the answer is true. So the first basic approach which you have came in your mind is that okay, you have to get the frequencies, right? So I'll take a hash map and we'll get the frequencies, and then I just have to check if all the frequencies are actually unique. So what I can do is I can push out all these elements in actually my another. So basically, firstly I use a hash map. I used a hash map to get this entire key value pair. Key is the elements of the array and value is nothing but the frequencies. Now I will just push out all these elements in one hash set. I'll push out all these elements because keys are always unique, so it will always give me answer as 4. Now I will push out all these values which were the frequencies I'll push out in another hash set, and if this matches, then voila, my answer is true. If it doesn't, which means as you can see, this has a size of 2, this has a size of 1. I'm saying unique number of elements, so for sure I have some duplicate. If the size is actually not equal to my keys, so it means I have some duplicate frequency count, which I don't want. So I'll just use this exact same thing. I'll keep a frequency array with which okay, I will get the frequency of all the elements of the array. Now this frequency, now you remembered I want to get all these values, which means the actual frequencies, into another hash set so as to compare it with my entire key size. So I will make another frequency set, and then I'll push out all the values inside my frequency set. So this is the frequency set array. Now we know that okay, an ordered map contains the key value pair. Keys are always unique, so for sure to get this size of this, I can use the hash map itself, and this I have pushed it in a set, so I can use my set itself. So I can use my frequency set. This is the frequencies of all the values in the array, and this is the frequency size, which is nothing but the keys, which are the actual values in the array. So if this is equal, which means I have unique number of frequencies. Unique number of frequencies, and the answer is true. So for sure, as you saw that I am using I'm iterating on all the elements of the array, so time is O of n, and in worst case what all possible number of unique values can be inside, because you will see that your hash set and your hash set, let me draw it again, your hash set and your hash map both will have unique number of elements. So let's imagine the unique number of elements is m, so space is O of m. Now although the problem is finished and this is the best possible solution for you, this is the best possible solution, but the interviewer might be a bit sketchy and might go and asking that okay, you cannot use your hash map or hash set, because he will tell you some constraints. That okay, as you can see, the constraints are like this. Because see, why we go about using our hash map and hash set is that we never know what is the values. So my hash set and hash map can handle even -1e6 to 1e6. It can handle big values also, but here he'll say, okay, I have very small values, which means -1k to 1k. Now you cannot use your hash set and hash map. Can you use something else? So for sure, we will just replicate what our hash map does. Hash map keeps track of the frequencies in a data structure which actually handles hash collision itself. Rather, we can just replicate how it actually internally works. It works on basis of an array. So we can take an array instead, and that array, if we keep track of the count of all the elements frequencies, that is, let's say, okay, 0, 1, 2, 3, 4, 5. So 1 at 1, okay, it will say that 1 has a frequency of 1. 3 has a frequency of, let's say, 4. 5 has a frequency of, let's say, 2. So this is how I can use an array. That is called as a counting sort. So I'll use an array instead, and I know that my element ranges are from -1k to 1k. Again, my array starts from 0. So I have to kind of say that, okay, I will use my array from 0 to 2 into 1000, so that I can map, okay, -1k value will actually be pointing to a 0. 1000 value will actually point into a 2k, so as to actually make sure that it is that, okay, I slided the window out. I slided the -1k to 1k window to actually a 0 to 2k window. Because I know that, okay, my array actually works on this window itself. So now instead of using my hash map, I'll use this array, which I will make of size 2k. I'll make that and I'll use that array itself. So as you can see, I initialize my k with the 1000. Now I'll simply keep on going on all of my elements. So I'll simply make a frequency array of size 2k plus 1, because you remember we can actually go on to indexes from 0 to 2k, right? So we made an array of frequency 2k plus 1. I'll go on to all of my elements, and then again, as I go into an element, I have to add a plus k, because, okay, this is the element. Let's say I have an element's value, it can be -1000. So -1000, I have to actually map it to 0. So as soon as I land onto any element, I will say, okay, add a 1000 onto it, and then you should get its frequencies, because my array can only contain the elements from 0 to 1000, with 0 to like 2k, which is starting from 0 itself. So I'll just simply add that k. Now, okay, my hash map function is done. Now, as you remember that I cannot even use my hash set. So earlier I was using my hash set to know the frequencies, okay, if the frequencies are, like, if I find some duplicate value or not. And again, one other way to find some duplicate value is using a hash set. Sorry, using a hash map also. Like, either you say, okay, 1, 2, 3, 4, the array sizes, which means the hash set size is this, or what you can do is, okay, you can just use a hash map and you'll say, okay, 1 has occurred, 2 has occurred, 3 has occurred, 4 has occurred, and okay, if again 2 occurred, which means I'll check in my hash map if it has occurred or not. That is if we are using a hash set or a hash map. But now interviewer has asked us, don't use it. So what we will do is, to check if something has duplicate or not, let's say if I just give you 3, 2, 4, 1 and 2, if I ask you if this has duplicate or not, the best thing is, okay, what you can do that again, when I said duplicate, I can have multiple frequency. I can have my 4 repeating again, my 3 repeating again also. So that can be many possible cases. So one very obvious thing which comes in our mind is that, okay, we cannot use it, we cannot use another actually frequency array of stuff. So we can simply sort it down. 1, 2, 2, 3, 4. If an element repeats, okay, at I and I plus 1, if I have something as same, which means, okay, my frequency is actually again repeating. So we'll use the same logic, that we will simply sort my frequency down, and I'll iterate on all of my elements in the frequencies, and I'll check my I and I plus 1. If they are same, return false, because I wanted that they should not be same. Ultimately, if I tried on for all the frequencies, and if it is not false, then I simply return a true in the end. Now, bhaiya, what is this case? Because as you remembered, it is a frequency array of size 2k. So for sure, many elements will actually also be a 0, which means they were not even present in your actual input array, ARR. So please skip those, because if it is not present, then why are you comparing it? Because if you start comparing it, then it can have 2 0 values, which can make it as a true. So it will start returning false, which you don't want. So please skip those ones. And that's how you can simply solve it in O of n, because you know that, okay, you have n elements, so you will iterate on elements. The sorting of the frequencies, because frequencies is, okay, unique elements in the array. It can be m log m. Now, because of us, we restricted the size, which is 2k plus 1. So for sure, it will be 2k log 2k. And for sure, space is also O of m, because we are using a size, array size 2k. So that's also a 2k. That's how, again, this is an approach which you might feel like, okay, it's taking more time, but depending upon the constraints, if I increase the array, if I just reduce this range and I increase this ARR, so this will be much better solution. But right now, with the current solution, this is the best solution, because these are both in the same range. And again, if this range becomes more, let's say my ARI becomes minus 186 to 186, so for sure the above range will be the best range. So it is depending upon the constraints that the interviewer might ask you, that how will you handle the constraints and what you think is the best possible approach for different constraints. And that is the reason it has been asked by so many companies, and specifically Apple, Google, Bloomberg, Amazon, Adobe, Facebook, and Rippling. Cool. Thank you so much. Take care. Bye bye.